Have you recently started with JavaScript, learned what the function, variable and object is, and now you're looking to build your first beginner-friendly project? Or have you been using HTML5 Canvas for a while and want to learn a bit more about how it works under the hood? Then this video is for you. In today's HTML5 Canvas tutorial for beginners, we will learn how to draw shapes with JavaScript, and we will use that basic knowledge in a powerful way to draw randomized Fibonacci flowers. Welcome to another edition to our Shapes of Nature creative series. Hi coders, welcome to my creative coding series where we learn front-end web development techniques by building generative art projects with just plain vanilla JavaScript. All the skills and techniques we learn here are fundamental JavaScript principles, are completely transferable and can be used to build websites, digital art, applications and games. In each episode, we add a couple of new techniques to our front-end web developer coding toolkit, getting you one step closer to your successful coding interview. In short, we make cool things while learning JavaScript. In today's HTML5 Canvas tutorial for beginners, we will draw shapes with JavaScript, and we will learn how to create so-called Fibonacci flower algorithm, also known as golden ratio or phyllotaxis. This is often seen in nature in, for example, pine cones, seashells, or sunflower seed arrangements. There is a perfect YouTube video that covers the basics of this principle, and then it goes really deep into what's happening mathematically. If you are interested and have 10 minutes to spare, there is a link in the video description. And if you want this principle to explain by Dan Schiffman in P5JS, you can watch his coding train video. And you can also watch all his videos while you're there, he's the best. Simply said, Fibonacci numbers create a sequence where each number is the sum of the two preceding ones, starting with 0 and 1. The sequence goes like this: 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, and so on. Fibonacci sequence starts with 0 and 1, and it is a very common interview question where you will be asked to write an algorithm that returns numbers that create Fibonacci sequence. To draw so-called Fibonacci flower, we do not necessarily have to start with 0 and 1. We can choose any two numbers to start with. If this is your first time here, let me know in the comments and say hi. My name is Frank, and I'm a self-taught front-end web developer. I learned everything I know online in my free time, mostly from YouTube and Udemy. What is your story? If you want to share, leave a comment and let's have a chat about it. This vanilla JavaScript coding tutorial will be focused on HTML5 Canvas element and its fundamentals. We will look into how it works under the hood, and we will investigate where are all these methods that allow us to draw shapes coming from. The first part of this video will be very beginner friendly, and I will take you step by step through Canvas setup and creating your first interactive Canvas animation. In the second part of this video, we will add a small algorithm that allows us to draw randomized flower shapes. And finally, in the third part of this video, we will put on our lab coats and do some coding experiments. Let's see where we can take this effect. I will do my best to make this as beginner friendly as possible. If you get any value from my tutorials, click the like button please. Other than generative art, I also do CSS animations and JavaScript game development, so you can check out my playlists if you want. Let's start coding. We will work with three files as usual. In index.html, we'll install CSS file, create HTML5 canvas element with an ID of canvas1, and link our JavaScript file. I called it script.js. In style CSS, I set canvas to position absolute. I give it border 1 pixel solid black. Actually, let's make the border 2 pixels. And I will also give it blue background so we can see its size. I want the canvas to cover the entire browser window, so I set its top position to 0 pixels, left to 0 pixels, width 100% and height 100%. You can't see it on my preview, but because I have border around my canvas, my page is showing scroll bars. If I want to remove them, I can set overflow to hidden on the body element. Canvas element is a special type of HTML tag that basically creates a drawing board where we can use JavaScript to create interactive circles, rectangles, lines, and so much more. We can use two different APIs to draw on Canvas. API in this case means a set of built-in methods like fillRect to draw a rectangle filled with color, or arc method to draw a circular path. These methods are part of so-called Canvas API, which largely focuses on 2D graphics. The other type is so-called WebGL API, which also uses HTML Canvas element to draw hardware-accelerated 2D and 3D graphics. So, to use JavaScript to draw on HTML5 Canvas element we have just created, first I need to save a reference to that element in a variable. I call that variable Canvas, and I point JavaScript to the correct HTML element by targeting its unique ID. I say const canvas equals to document.getElement by ID, and I pass it ID I gave it in index.html, which is canvas1. As I said, we have two different APIs that allow us to draw on Canvas: Canvas API and WebGL API. I will use Canvas API, which focuses on 2D. To do that, I create a new variable. I call it, for example, CTX, shortcut for context, and I set it equal to canvas, which is a variable from line 1, dot get context, and as an argument, I pass it 2D. This tells JavaScript which one of these two APIs I want to use for my project. If I wanted to do 3D, I would pass it WebGL here instead. There is also an optional second attribute where we can adjust settings like anti-aliasing, alpha, depth, power preference to set how much power we want to draw from our graphics card. This is especially for WebGL. I will cover that in some other tutorial. Let's just keep this video as simple as possible and cover the basics of 2D. So now I can call all built-in Canvas API 2D methods from this CTX variable. Methods that allow us to draw a line, circle, square, and so much more. I will show you what I mean in a minute. I set canvas width to window in width and canvas height to window in height to make sure the canvas covers the entire browser window. All this code will run just once on the initial page load, so if you want to change canvas size when you resize browser window, this code from line 3 and 4 would have to go inside resize event listener, so it runs every time resize event occurs in browser. I will show you a bit later. So now we are done with Canvas setup and we are ready to draw. I want to draw a circle first. The way Canvas API draws circles is using arc method, which can also be used to create curved lines, so-called paths. First, we create programmatic path, and then we can fill it with color or just outline it with stroke. To draw a path on Canvas, first I have to call built-in beginPath method. Think of it as telling JavaScript you want to start drawing by putting pencil on the canvas. Then I call CTX arc, which expects at least 5 attributes: position on the horizontal x-axis, position on the vertical y-axis, circle radius, which will determine its size, start angle on circular path around the starting coordinates, and end angle. So I will set position x to 10, position y to 10, radius to 5, start angle will be 0, and end angle will be math.pi times 2, which is a value in radians that converts exactly to 360 degrees, which is a full circle. Then I call close path and CTX fill, which will fill our path with color. If we don't declare any color, it will be black by default. I can change its coordinates by adjusting these two values. And I can make it larger by changing its radius property to, let's say, 50. In style CSS, I remove border and background on the canvas. And back in script.js, I set fill style to red. I can also call stroke, which will highlight the circular path with border. By default, this border will be 1 pixel wide and black color. I can change this by setting line width to 5. Let's push it down a bit. And set stroke style to blue. Notice how I call all these built-in methods like beginPath, arc, and closePath from CTX variable we declared on line 2. That is because on line 2 I set CTX to be equal to whatever canvas.getContext2D method returns. You might have heard that almost everything in JavaScript is an object. That certainly applies here, and getContextToD returns a built-in object called CanvasRenderingContext2D. On line 2, I am assigning that special object to our CTX variable, and if you console log CTX, you can see the object itself. Its properties like fill style and font, and all of its built-in methods. That's how Canvas 2D API works. We are just pulling these pre-built methods from this object and calling them the draw on canvas. Back to our project, so far we have drawn a circle. We can also draw a rectangle, which is a bit simpler. All we need is a built-in fillRect method, and we pass it 4 attributes: X and Y position and width and height, like this. We can change its position and size by changing values here. I will delete the rectangle now. We have our circle. How do we make it move? I create a custom function called animate. Its job will be to create our animation loop, which will just basically redraw canvas over and over, creating an illusion of movement. So first, there will be some code to draw each frame, and then I pass it built-in requestAnimationFrame function. All this function does is it calls whatever function we pass to it as an argument. If I pass it animate, the name of its parent function, our animate function will just call itself over and over, creating an animation loop through a programming principle called recursion. I take all the code we wrote to draw our circle and I put it inside the animation loop. Now we have a blank canvas because on line 8 I declare a function I called animate, but it doesn't run its code. To run it, I need to call that function saying animate and brackets like this. When I do that, JavaScript jumps from line 20 back to line 8. It runs all the drawing code to create our circle between lines 10 and 17. And on the line 18, we have a requestAnimationFrame that makes JavaScript jump back to line 8 and call animate again. This will be happening over and over, so we have our animation loop. Everything is being redrawn now, even though it looks static. To prove to you that animation loop works, I go to line 14 and inside arc method, I replace radius of 50 with a variable. I call it size, and on line 6 I declare it and set it equal to 0. Notice I'm using let variable instead of const. That is because size is 0 now, but it will change for every frame of animation. I want to make the circle grow. So on line 10, inside animation loop, I say every time this loop is run, increase size variable from the line 6 by 1. And since this variable is part of our arc method on line 16, it will affect the size of the circle that's being drawn for every frame. Like this. Click the like button please if you're getting any value from my tutorials. Subscribe and hit the bell icon if you want to be notified when I release a new creative coding video. I can change value on line 10 to set how fast our circle is growing. I can also make it move. I replace X coordinate on line 16, and instead of drawing our circle at a starting position 100 pixels from the left side, I place a variable here. I call it position X, for example, and on line 7 I declare position X as a global let variable, and I set it to 0 at first. Inside animation loop, I say for each frame, increase position X variable by 0.1. Maybe a bit more. 0.5. And we have a growing circle that moves to the right. You can see it's leaving a path behind. That is because we still see old frames. If we only want to see the current frame, I can go inside animation loop and call ctxClearRect method. This will clear specified area of canvas from any old paint. I want to clear the entire canvas, so I pass it 0, 0, canvas width, canvas height. And now we can only see the current frame, because old paint is being deleted between every animation frame. I can change values on size and position X variables to make the circle grow and move slower or faster, depending on what value I assign it to. We can keep all this code inside animation loop like this, but it's starting to look a bit messy. I would prefer to have our drawing code in a separate function for clarity. I go up to line 9 and I create a custom function I call, for example, drawFlower. Then I cut all the drawing code from inside animate and I paste it inside the custom drawFlower function I just created. Now our drawing code is clearly separated and I can just call drawFlower from inside animation loop, like this. We still get the same result, but our code is cleaner now. I can also replace vertical y coordinate with a custom variable. So on line 14 I replace 300 with a variable I call, for example, position y, and on line 8 I declare that variable and set it equal to 0. Then on line 27, inside animate, I say every time animation loop runs, increase position y variable by 0.5. And this is what happens. We create a simple vector for our circle. It means we give it direction and speed. We can change these values to make it move in a different direction, like this. The base principle with algorithmic flower is circle movement. How do I make our circle shape to move around canvas in a circular path? Don't get scared now when I say word trigonometry. It's not that difficult, I promise. We have covered basic canvas principles. Now we are venturing into intermediate territory, but I will still do my best to keep you with me and I will explain everything I'm doing. I create a variable I call angle and I set it equal to 0. Inside animation loop, I set angle to increase by 0.1 for every frame of animation. On line 26, I comment out code that increases size, and on line 6, I set size to be a static number, let's say 10 or 20. Actually, let's remove the variable completely, and I will hardcode radius size 20 inside arc method on line 15. On line 25, we have a variable that determines horizontal position of our particle. I will multiply it by math.sign built-in JavaScript method, and I pass it angle, the variable we declared on line 8, and which we are increasing by 0.1 for every frame of animation on line 27. All that math.sign does is it returns a number between -1 and +1. This number represents the sine of the angle we gave it in radians. Very simply said, if you call math.sign and pass it a number that slowly increases, in this case we pass it our angle variable, it will fluctuate between -1 and +1, so the resulting movement will look like this. Let's push the circle away from the left edge by increasing position x variable on line 6. See how its only horizontal movement is wobble to left and right. If I increase this number on line 25, it will increase the range of the movement. By default, math.sign cycles between -1 and +1. If we multiply it times 5, the range will be -5 to +5. I can also do the same for position y. I say 1 times math.sign and I pass it angle variable as an argument again. All math.sign is doing is translating ever-increasing number inside angle variable to a range between -1 and +1. If we use sign for both x and y positions, we will get a simple back and forth path like this. Let's move it down by increasing position y variable on line 7 to 100. If I want a circular movement, I need to change sine to cosine. Sine and cosine work together in sync to map a path along a circular area. Cosine is the same as sine, it's just returning the opposite value from the range between -1 and +1. Don't worry if you can't understand this 100% yet. All we need to know for this effect is how to use these methods. It will make more sense if you use it more than once. So if I change 1 to 5 on line 26, our ellipse path will change into a perfect circle, like this. On lines 25 and 26, I can change this value to make the circular path smaller or larger. I can also adjust value on line 27. On lines 6 and 7, I can set these values to be in the middle of the canvas. But as you can see, it is not exactly centered. We will fix that in a minute. Right now, we are clearing canvas after every step of animation. What happens if I stop clearing the canvas so we can see the old paint as well? I comment out line 23 and now I can see all previous positions for our particle. This will be crucial to draw algorithmic flowers. Some of you might already see how we will go about drawing the flowers. Basically, all I need to do now is to slowly increase the size of circular path as the particle spins around. Before I do that, I will restructure and clean the code up a bit. Inside draw flower, I create 3 variables, angle, x and y, and I set them to 0. These variables will completely replace position x, position y and angle variables from lines 6, 7 and 8. Actually, let's not make it confusing. I will keep the same naming. So on line 12, I will call the variable position x, and on the line 13, I will call the variable position y. Now I can delete variables with the same name from the line 6 and 7, and I can also delete angle variable on line 6 because it will be replaced by angle variable inside draw flower function. I will also need one more variable. I will call it radius. This will determine size of circular path our particle is taking. I will show you in a minute. I go down to animate function and I delete everything between lines 25 and 28. On line 6, I create a variable I call number. This will simply increase by 1 every step of animation, and each time it increases, one particle or petal on our flower will be drawn. I also create a variable I call scale, and I set it to 10, for example. This will play a role in making our radius grow, so our flower grows from the center outwards. On the line 10, I say angle is equal to number variable from line 6 times 1. This number will determine final shape of the flower. I will show you in the experiments part of this video how it works exactly. Radius on line 13 is equal to scale variable from line 7 times math.square root, and I pass it number from line 6. Also, I will explain in a second. All I want to happen here is for the radius to slowly increase to draw layers of petals in our flower, but I want it to increase very slowly, so that's why I use math.square root. I cut position x and position y variables and I paste them here. They need to come after the radius. Because we need radius to already be calculated, so we can calculate current x and y position for the particle. Position x will be radius times math.sine, and I pass it angle like we did before. And position y will be radius times math.cosine, and I pass it angle as well. I want position x and position y to map values along a growing circular path. To make sure the path is growing and our particle is not just being drawn on top of itself over and over, I go to line 24 and I say number plus plus, which will make it increase by 1 for every frame of animation. Our number variable was declared on line 6, and as it increases, it changes values of angle variable on line 10 and radius variable on line 11. And then both angle and radius variables are used on lines 12 and 13 to calculate current position x and position y coordinate for our particle. If you look at this code closely, all that is happening on line 10 is I am increasing angle variable because it's equal to number variable that is increasing on line 24. And then I am passing that ever increasing angle variable to sine and cosine on lines 12 and 13, same like we did in our first simple example before. Sine and cosine simply just transfer any angle we pass to it as an attribute into a range between -1 and +1. And we use that behavior to map position along a circular path. And if we multiply this number by anything, let's say 5, the range will increase from -1 to +1 to -5 to +5. So the circle will grow. In this case, on lines 12 and 13, I am multiplying sine and cosine by radius variable from line 11. Radius variable, again, is simply just a very small, slowly increasing number that makes sure the radius of circular path our particle is taking is getting larger and larger to draw the final flower shape. The flower is being drawn from the top right corner, so I can just move it to the middle of canvas horizontally, here on line 12 by saying plus canvas width divided by 2, and vertically on line 13 by saying plus canvas height divided by 2. I can change color of the fill here on line 15, and I can change stroke color on line 16. Look at what we can do with just 37 lines of JavaScript. Time for some experiments. It can look much better than this. Click the like please if you're getting any value from my tutorials. But before we do that, let's just quickly look at the code. First, we did our initial canvas setup on lines 1 to 4. Then we created some global variables to use as settings for our algorithm on lines 6 and 7. This effect is drawn by a single spinning particle. Inside the drawFlower function, we first calculate position for this particle for this particular animation frame on lines 10 to 13. Then we use Canvas API built-in drawing methods to draw a shape we want. If you want to replace circle with something else, you can replace it with a square, rectangle, star, hexagon, or image. You can do that just by replacing the code here. For each frame, we also increase our number variable on line 24. This will cause the particle that draws our effect to move around. And lastly, we create animate function, which has only one job, and that is just to run drawFlower function over and over and make the single particle spin around in circles to create our final flower shape. We could replace this with JavaScript setInterval, but request animation frame is better because it will adjust to your screen refresh rate. Always try to use request animation frame like this over setInterval for your generative art projects if you can. It's a good practice for performance especially. To prove to you that this is just one particle spinning around that draws our effect, I can just go down here to line 29 and I can uncomment clear rectangle, which will remove old paint between every animation frame. Now you should be able to see what's happening with this effect. Single spinning particle that draws everything. I comment it out again and let's do some experiments. Let's make it look good. Look what happens when I change this value on line 10. Every time I change this value, it draws completely different flower shape. I can spend hours just playing with this by tweaking values here, because you can also put very small numbers here. Look what happens if I go to line 19 and I replace size of our drawing particle with number variable. Remember that number variable is declared on line 6 and it increases by 1 for every frame of animation. So the particle that draws our flower effect will be growing. I don't want it to be growing endlessly. Let's introduce some limits. On line 31 inside animate, I say if number is more than 300, return. Return in JavaScript is a special keyword and it will make function to stop on that line. So when a number variable we are increasing on line 24 grows to 300, animate function will return on line 31 and request animation frame on line 32 will not run again to serve the next animation frame. When a number reaches 300, animation will stop. I can change limit to 100. I change fill style. Have you heard about global composite operation property on Canvas element? I used it for a couple of effects here on the channel before. This property of Canvas 2D API sets what type of compositing we want when drawing new shapes on Canvas. What it means in simple language is by using this property, we decide how individual shapes on Canvas stack, interact and overlap, similar to layers in Photoshop. There are around 26 different settings. If I set it to destination over, new shapes are drawn behind the older ones. Drawing goes kind of backwards and it's really good for this particular flower shape we are trying to achieve in this video. Let's set line width to 4 and fill style to gray. I can change shape of flower by changing number here on line 11. What is happening here is just simply I am telling the particle that spins around circular area to draw our flower how far it should skip between every step. Different interval between skips along a circular path will create different shapes. If I use a very small number here, you can see it doesn't even skip far enough between stages where individual circles are drawn and we just get the shape like this. Eventually, it will give us kind of a snail shell, which I really like. Adjusting if statement on line 32 will allow us to draw larger flowers. I can play with this and tweak all these values to see what shape it gives us. I can also show you how to give it rainbow colors. On the line 16, I set fill style to HSL color declaration. This takes 3 attributes: hue, saturation, and lightness. If I set hue to 1, we will get red color. The first attribute can be anything between number 1 and 360, and each number is 1 degree on HSL color wheel, so changing this number will cycle through the entire color spectrum. I made a special video about colors on canvas. If you want to learn more about HSL color declaration and canvas gradients, you can watch it later. When HSL reaches 360, it just starts from the beginning and the cycle starts from the red color again. I can create a global variable I call hue, and initially I set it to 0 on line 6. Now down here on line 27, inside animation loop, I say for every frame increase hue by 1, hue++. On line 17 in fill style, inside HSL color declaration, I just replace value for hue with this variable to make the statement dynamic. Now if I run the code, we are cycling through all the colors as the flower grows. I try to give it black stroke. If I wanted to cycle through colors slower, I can say only increase hue by 0.5 for each frame of animation, here on line 27, by saying hue plus equals 0.5. Also, maybe I don't always want to start from 0, which is red color. Maybe I want to start from a random color whenever new flower is created. To do that, I simply set the initial hue on line 6 to a random number between 0 and 360. And now, each time new flower is drawn, we start from a different color. I will make a special video on global composite operation because there is so much more we can do with it. Click the like button please if you're getting any value from my tutorials. Subscribe and hit the bell icon if you want to be notified when I release a new creative coding video. If you want more generative art, vanilla JavaScript game development, or CSS animation, check out my playlists in the video description down below. Thank you so much for watching, and well done if you managed to follow along all this way through. See you next time.